Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 22, we will look into data access and manipulation, and this is the second part of this three-part lecture. So, in this lecture, the concepts that we will be covering will be on data frames, then importing Excel files, and then basic database access, and we will demo that by using SQLite, which is one of the basic database that Python provides us with, and SQLite database reading, writing and querying data would be also covered. Now, before we start moving into databases or importing Excel files, first let us understand data frames. We have been talking about that in the previous lecture, where in the pandas library we saw that pandas provide a lot of these data structures, series, data frames and so on. And data frame is one of the most common data structure you will find, you will be seeing that it is used everywhere for machine learning, for anywhere wherever we want to store a CSV file, and most CSV files are of 2 dimension, and when we store that, a data frame can be utilized. So, here we are using this CSV file, which is urban land records data. Now, you can see the CSV file at the top, that is, I have not given you all the rows for the CSV file, but you can see the first, the title row, that is the parcel ID, word, land use, area square meter, owner type, access value in INR, property tax in INR, registration date, encroachment flag. So, these are the different columns. Obviously, encroachment flag is yes or no. It's a binary thing. So, is that particular plot encroached or not? Basically, we are storing data regarding each parcel or each plot of land and which ward it is, what is the land use, allowed land use in that particular plot, what is the area of that plot, owner type, is it private or government, and what is the value of the property and the property tax that has to be paid for that property, and when this particular property was registered. So, this is basic data set. And what I have done is I have also give you, instead of keeping it in the CSV form, which is difficult to see and understand, I have also given you the form which is in Excel form. That is this parcel ID, ward, land use. This is the Excel table. I have just put the CSV in the Excel file, and this is how we can see the data under each columns. So, now what we will do is we will first create a data frame, we will read the data from the data frame, and then we will try to demonstrate you the different functions which we have learned in pandas library, that in which we were manipulating the data, or after we have imported the data CSV file into our data frame, then what sort of manipulation, how do I access the data, all these things we will demonstrate. So, in this particular program, we are using the CSV file that we just showed you in the previous slide, and first we are importing pandas as PD, which what it means is this loads the pandas library and referred to it as PD, right. So, that means we are importing it and we are just calling it PD. Why? Because it is a acronym. Every time I do not have to use pandas, we say PD, that is all. So, it is a short form of pandas, and that is why we are saying PD.readCSV means we are calling the read CSV object of PD. So, this read CSV object actually loads the CSV into a data frame, and it converts registration. Okay. So, that when we are doing that, that means again we are calling the CSV file urban land records, and obviously this file, if it is there in the same folder as the Python program, then no issues. Otherwise, we have to specify the exact location of that particular file by giving the full path, that is C:/ or D:/ whatever it is. So, we are doing that, and after doing that, what we are doing is within that data frame, there is registration date is one of the values, and we want to convert that value into date. So that means we convert registration date from text to a date time data type, which will enable us to do time based analysis like before this date, after this date, and so on. So the next command actually does that. Df registration date, we are referring to that particular column, is equal to pd to data frame. We are calling the data frame to data frame function, and then it is converting the df registration date into this particular new to the date time format. And after that, what we are doing is we are printing the first 5 rows. So first I am just printing the after giving a slash in, that is next line, we are saying head dot slash dash dash head function colon first 5 rows. So that would just get printed, nothing else. Now to actually print the first 5 rows, we are calling the function df dot head. So print within that we are passing df dot head, and it will print the first 5 rows of that particular data frame. And similarly, if I want to press the last few rows, or in this case last 3 rows, we will say print the tail. So df dot tail, and 3 is given to specify the last 3 rows would get printed. Then when I say print dot df dot shape, it will tell us what is the shape of this particular table, how many rows and how many columns. And then if I say df dot columns, it will print me the columns that are there. And then if I say df dot data types, d types, then automatically it will print the different data types of each of these particular columns. And finally, I can print the schema of this particular table, and not only schema, the missing values of that. And for that, I will type in df.info. And if I want to print the missing values per column, then what I am doing is I am calling df is na is basically is not available. That means data is not there. And dot sum, actually what we are doing is we are combining multiple functions. So we can add a series of functions. So you see is na dot sum, is na in this case is the dot sum is the function, is na could be an object, and then we can also have series of functions. Sometimes we do that in SQL alchemy also. We will see that we can do those things, and this is na, and this thing ensures that it is summing up for each of these columns what are the number of missing values per column. So that is what it is doing, and that we can print using this print command. So just to go back, when I say this first 5 rows, you see the output comes over here, where you can see that head first 5 rows is first printed, and then actually the first 5 rows starting from 0, 1, 2, 3, 4, these 5 rows are being printed as an output for this first command over here, right? Then we continue with the same program, print n describe the numeric summary. This will get printed, but what it will do is it is actually going to print dot describe. This will ensure that it will ensure the different values for the columns area square kilometer, assessed value, and the property tags. It will find us the count, the minimum, maximum, standard deviation. All these things would be shown using that. So the describe function. So you can always go back to the previous lecture. You can check the different functions which I have listed, and it is listed there, and the purpose of that function is also given there. Then if I want to access data or a particular row from a particular row or a particular column and all, I said we can use the ilog command. If it was via label, it was the log command. So here I can specify data from which row. So df.ilog0 will print the first record, that is row 0, right? And then if I give 0 colon 3 comma 0 colon 4, the first 3 rows and the first 4 columns would get printed. And that the actual command is df.ilog 0 colon 3 comma 0 colon 4. And similarly, if I want to print the position at 5, that is at column at position 5, then I will say df.ilog colon comma, I am not giving anything for the row, I am just giving the position for the column, which is 5. And so this part will show that I will show you the outputs, of course. So it will show the exact location. If I want to print something from a particular row, particular column, all this could be getting printed. Then I can run some form of queries over here as well, right? So it's a form of query. It's that basically it's a conditional statement. So what we are doing over here is we can find out which are the buildings which have got residential land use and area is above greater than 150. So very easily we can do that. So first I'm just printing. If you don't even print anything, doesn't matter. You can just directly type df.query within print, of course, land use equal to residential and area underscore square meter is greater than 150. So it's like a query kind of conditional statement, and when you do that, you will get only those values which satisfy this particular condition. And similarly, encroach parcels, if it is y, if it is yes, I can print those particular rows as well. So df.query, print the data which is encroach flag equal to y. Now this actually shows access of data, right? And this is access of data, and this actually shows how do I with conditional statement also get some data out from a particular data frame. Now I want to do some some operations, statistical operations, basic ones, and want to manipulate the data. For example, the first thing is I want to check that if there are some empty spaces in the area column, area underscore square meter column, and if so, then what I want to do is, like, if it is empty, then I will fill it up with the median values of that particular column. That means, so usually that's a very standard way of doing data cleaning or data pre-processing before I actually start doing analysis. Once I collect data, it may so happen that for some reason one value has not come, right? So how do I fill that value? So one strategy is I take the average of all the values and then put that there. So in this case, one of the central tendency, that is median, instead of mean or instead of mode, that has been utilized to fill up those particular value, right? Now this is one part. Then again, what we can do is we can do some internal statistical calculation, and then once we have done that, we can also add new data to a particular or a new column as well to a particular data set in a data frame and so on. So over here you can see that we are doing some basic calculation where we are estimating the tax rate, and this is found from property tax underscore INR divided by assessed value underscore INR. So that will give me the property tax rate. Now because we are dividing, it may so happen assessed value could be 0. In that case, it will return an error. But to prevent that, I am using this replace 0, this PDNA. If it is with, it will be replaced with NA instead of 0. If it is 0, it will get replaced with NA, and then that error will not come, right? So so replace 0 PDNA avoids division by 0 for in this case for government land with access value is equal to 0. So then what I can do is I can also do some utilize some aggregation functions, like for example over here, ward summary is equal to df.group by based on the ward. For each ward I am grouping, aggregate what I am aggregating. I am aggregating parcels, total assessed value and the total property tax. That means all this will be summed up for each ward and then it would be shown. And then over here, after that I can sort the values, because I am doing a group by. I can sort the value based on total assessed value, and it could be in the ascending order. So in the descending order, so it is ascending equal to false. So that means when I am ordering by, I have to order by as per some criteria, that is based on the total assessed value of each ward. And where I am getting that? I am getting that by already aggregating that using this sum function that will aggregate all the values of that particular column of that particular ward. Sorry. And so finally, once we have done that, we can print the summary, ward summary, this particular variable or list that we are already creating over here. And after that, what we can do is then we can save the data to the CSV file, urban land records, and we can say that this is a clean CSV. That means we are making changes and all, and index equal to false is given, so that in this case the index value, that is in a data frame we are having index value. So if I go back to the previous slide, so these are the index values, right? So these index values are not stored in the CSV file. So index is equal to false, and then we can print that particular CSV file again to see if everything is fine. So let's see the output in each case. So the first 5 rows already I have shown. When I type in df.tail for the last 3 rows, it will come like this. You can see the last 3 rows have been returned. When it is, we are saying shape, this is what it will be returned, that is 10 and 9. So this is the number of rows and columns in that sequence. Then if I say df.columns, you can see that these are the column names which have been printed out. So that will be shown. If it is the data types, df.dtypes, then it will say parcel ID is a kind of object, and object is a variable type where strings and some other things could be stored. Then area underscore square meter is a float 64, owner underscore type is again object, then access value INR is INT 64, and registration date is date time, because we already changed that already date time earlier. And then encroachment flag is also an object. Then coming to df.info, you can see that df.info will return you this particular information. So it is returning the compact schema, the missing values. So everything is returned, and so you can see that for each column, if there are 10 values, it is not null, and all these values are then area square kilometer, there are 9 values, so 1 is missing. So and then the data types. So it gives the overall schema and the missing data points in this particular table. This information is returned via this command. Then missing values per command, if I want to print them out, so df.is na.sum, that same function that we did earlier, it will show us that for each of the column I am summing up the missing values, and eventually we are seeing that area square meter is the only one which is missing a particular value in the column. But if it was missing 2 values in this column, this value, because we are summing it up, it would have become 2. Okay. Now coming to the describe function, when we are describing the function, of course it is for these 3 fields, that is area under these 3 columns, area underscore square meter, access value underscore INR, and property tags. You can see over here that we are getting count, median, standard deviation, minimum, then the percentile values, and then the maximum values as well. And then finally we move on to the location ones, that is how do I access a location. So in the first one I am accessing the location 0, ilog 0, that is the row 0. So row 0 values are returned over here. For each of for this row, all the values are returned for each of the columns. Then for location first 3 rows and first 4 rows, if I want to print, so this would be what it is coming, that is the first 3 rows and the first 4 columns are printed. Then this column at position 5 is printed. So in this case only column at position 5 is getting printed. So for the query part, you can see over here that the first query that we run was if it's a residential area and greater than 150. So we get 2 records 0 and 8, which are both residential as well as those are having a larger square footage. And then comes the encroachment query, and here you can see that these are the N2 plots parcels of land where these are encroached. These are all Y. And finally we come to this what summary, that is the aggregate function, that is after I have done all this I can print the word summary where I am grouping by and then summing it up based on the access value and so on. So overall you can see for each word which is not repeating, we are getting how the number of values for that and the summed up value of the property, right, access value of the property. And that is what we have given you, and finally we are saving this value to urban land records clean.csv. Index is false means it removes the row indices, which I told earlier, and then we can print that we have saved the clean file saved as urban land records clean.csv. Now Next, we will move into how to import an Excel file. More or less, it is similar, but only difference is now that we have learned pandas, we will do it through pandas. And using the pandas library for Excel, as we already discussed, it's a high-level access. If I don't want to have so much amount of functions which we want to utilize from that, we can use this open pixel which gives us low level access. And it and in any case we have to OpenPixel is a Python library to read write Excel 2010, XLS, X, XLSM, XLTX, all these different files could be read using this. But in this particular example, we are going with pandas to to access Excel files. So obviously, first I have to install pandas in the first place, because till now we have not installed pandas. By default, pandas may be there, but in any case, if it's not there, you can install using this particular command pip install pandas, or if it is within the Anaconda framework you are doing, like we are doing with all the examples, it's in the Anaconda framework, we are using Spider and all, you can type in conda install pandas in the command prompt, of course. And then you can install pandas first, and then we can start writing code where we are importing pandas library. So any library you want to utilize, you first have to import that within your IDE, within your structure coding window within the coding framework, and then only you can incorporate that, and then the interpreter will be able to read into that particular functions, incorporate that code within your program and so on. So next we are importing, we are writing data to an Excel file household survey. So of course we are importing pandas as PD, then data to write, same as earlier that we did in the previous lecture. We are first specifying what data needs to be written, and this is household ID. This is sort of a dictionary with again a list attached. So household ID, these are the list, number of people, these are the list, household income, these are the list, but these are all part of a dictionary thing, that is housing type with colon, these are the values for that particular key, right? So this is how we are doing it, and then we are saving this value in data to write, and then pd.dataframe data, we are putting data to write, and we are putting that in a data frame first. And once we have done that, then we are df to Excel. That means we are saving this in an Excel file, which is household survey XLS. Again, this will be saved in the same folder where the Python program is, but if you want to save it somewhere specific, you can give the pathway as well. And then it prints household survey data has been written to household survey, and df.read pd.read Excel. So once I have saved the data to the Excel file, now I am reading the Excel file. Or in any case, in a program, if you just want to purely read a Excel file, you just type it like this, and then you can print the data. And once you have printed the data, you can display the data as well. So df._read is actually displayed by using the print command. So df.read actually contains the data which is coming from this particular Excel file from the read Excel command. So this is another example, import pandas as PD, df equal to pd.read_Excel. This is the file, but here what we are doing is, along with the file name, we are also giving the sheet name. So the idea is, if there are multiple sheets, you have to incorporate them in different separately, and then you can concatenate that, right? So in case of multiple sheets, different data frames are created separately, and then we concatenate for read Excel method. So the Excel method takes the argument name, that is the two arguments within which the street name, and then the index column, that from which column I can save the data, that I can read the data, that also could be specified. Here we have not done, we have taken the entire this particular sheet itself, the total sheet. Now I can also concatenate both the sheets into something like a new data frame, which is new data in this case, and then pd.concatenate I can put in sheet 1 and sheet 2, which we have earlier incorporated. So that is another way we can do concatenation. Anyway, so coming back to the program, so you can see the df.head, df.info, df.describe, we have already know what they will do. One will show the first few rows, then the one will show the structure and the data types, and finally the summary like mean, median, max, minimum, all these things would be shown. Then what we can do, same way we can handle the missing data. We fill it with the median values. So df area underscore square meter. If there are values which are missing, then we will fill it up with the median values of this entire column. So this is what it specifies. Now then we are creating this df dot query where we are doing a conditional statement to filter the data, that is land is equal to residential and area underscore square meter greater than 150, and this is the there in df dot query. It will store the we are passing this condition, and automatically the values will be stored in large res. Now I can do the same thing which we did earlier. So we can calculate the tax rate, which is property tax divided by assess value, and then again we will replace, in case assess value is 0, we will replace that with NA. So that's why with df assess value it is saying dot replace 0 comma pdna. Now then I can give a summary of the I can store the data in a summary, which is df dot group by. I'm grouping the data based on word, and we are showing assess value in INR, and we will sum it up and then only we will show it. So finally, once we have done that, then we save this data to Excel, and it will be saved to urban land records processed XLS, and again index will be false, which means we are not storing the index values. And finally, we can print large residential parcels, and then within that the large underscore res, that is the query that we run earlier, that would be printed, and then in the next one I can print the summary that also could be printed, which is like we can this value over here, that is group by value, also could be printed as well. Now coming to database access, using not directly accessing like Excel or so on. If I want to access a database, like for example, why do I need to access database in the first place? So pandas are usually used for data manipulation, analysis, and so on. So that means if I open a file in the memory, I can manipulate the data and then I can save it back, right? So usually we do it for merging, reshaping, selecting, statistical analysis, and many kinds of things. But suppose I want to deal with large amount of data, that means it doesn't fit into the memory, right? Suppose a database contains millions and millions of records, so it may not fit into my computer memory. So in this case, it is better to send instruction to the database so that changes are there, instead of bringing that again back and forth into the program and then working on it, right? So sometimes that results in more efficient operations, and particularly for joins and aggregations and those kind of things. And so that means we need to access database from Excel. That means it's not like we can just open a CSV file and then we use a data frame to store that value, then we can modify, manipulate, do some basic calculations, and then we can again do machine learning and all these things, right? But at the same point of time, we need to also access databases, because sometimes data is huge amount of data is there in database, and we can directly send in SQL statements, which we have done earlier, to extract the right data that we require. So to access and interact with an SQL database, with an SQL database, libraries are required. Now, what are these libraries? Libraries means this is a special group of functions which gives us the ability to access a database. So for example, the library that is there is SQLite 3 for SQLite database, which is inbuilt into Python. Or now SQLite database we will talk about. So it's an inbuilt database in Python. Or it could be library like PyMySQL or or scicop G2 for MySQL and PostgreSQL databases, and both could be used respectively, right? For PyMySQL it is for MySQL, and scicop G2 will be for PostgreSQL database. Now, SQLite is a very efficient serverless and self-contained SQL database engine. So, earlier we have learned about servers and how to configure them to a certain extent, right? So, but in this case we don't require a server, and it's a self-contained SQL database engine in the Python framework, and it's simple and easy to integrate into applications, obviously, but it's not that also, it's not like we can do many things with that actually. So, it is ACID compliant, that means atomicity, consistency, isolation, durability, all the basic properties of RDBMS is being covered, and it is more or less, all SQL standards are followed, and it could be either a local, it's a local or a client storage. So, it is sometimes you can say it's more secure in that way, and there is no need for separate database server processes like scripts to allow access of data and so on, and other complex configurations of security and all could be avoided when we use this database. Now, this SQLite database even could be used from C++, like it's a legacy, it's object-oriented programming, but it's a old programming. So, here you can see hash include SQLite 3.h. This is the way when in C++ we write programs. Hash includes that particular library or those kind of code or functions, and then int main is the main program within which the body runs. Sometimes we write functions outside, right? Same as in Python that we showed earlier. So, def main was there. Similarly, here int main is there. So, SQLite 3 start db int rc rc equal to SQLite 3 open. So, first in all cases you will see that when we are accessing a database, first we have to open the database. Then if the connection is okay and all, then we will do the commands, like we will do something with the database. We can extract data, we can select data and so on. In case the data is returning some error and all, then error handling has to be done. That is, if this error comes, what to print, if that error comes, what to print and so on. Otherwise, sometimes it may stop the program, right, if you don't do proper error handling. And then SQLite, finally, once we are done with the work, then we close the database, and that is what is done over here. And finally, the int main returns 0 to n. So, this is how C++ programs are written, right? But obviously, we will look into our Python program. So, over here we are importing SQLite 3, then con equal to SQLite 3.connect household survey.db. So, if already the database is there, it will open it. If it is not there, it will create a new database. Again, this could be as per the pathway you can also specify. And then cursor equal to con.cursor, this cursor command actually help us to execute SQL commands. That means we are executing queries in the database itself directly. I am not writing code here, like we will also learn that in SQL Alchemy or in ORM frameworks. We don't do this, right? But over here what we are doing is we are opening a connection with the database using the database connector, and then we are directly sending queries to the database, and that is happening over here. So, the cursor actually help us to execute this SQL command, right? So, the first cursor command is cursor.execute, that is to create a new table. If it doesn't exist, it will create a new table called household survey, and it will have ID, the first value is ID, which is integer, which would be a primary key. So, I can create all my, this primary, say, foreign key, all these things we can also specify. So, household ID text, household number of people is integer. So, I can give the data types of all the different columns or the attributes, and we are ready to create a new table. Once we have done that, we can insert data. So, first I create this, data structure where I'm storing all these values. So, data to instruct is that particular data structure in this case, and we are storing this, and then using the cursor.execute many command that actually allows us to insert multiple rows into the table at once. I can put what data to add, that is data to insert, right? But of course, we have to give it in a format. So, that means insert into a household survey, similar to SQL statements which we have learnt earlier. Household ID, number of people, household income. So, first it specify in which columns the data would be incorporated, then how many data would be incorporated. So, these question marks are nothing but placeholders. Sometimes we use ampersand, sometimes we use percentage sign, sometimes we use percentage signs, sometimes here we have used a question mark sign. So, and then what data to be inserted? So, that is data to insert, right. So, that means data to insert is already the values that we have already stored earlier. So once we have done that, that means we are already inserted the data, and then if I give con.commit, the data gets saved permanently, right? And then I want to select, I want to see the data what we have put in, right? So we will say cursor.execute, select star from household. So you already know when I say select star, that is basically a SQL statement where all the records are returned, right? So once the query is executed, it will return back something. So I have to store it somewhere, right? So cursor.fetchAll will actually fetch the records from the database, and it will store in rows, right? So it will fetch in row. So that means this rows will be the structure where we are storing whatever is written from the query, right, or rows of data. So then I want to print this particular rows. So of course I will run a loop. We already know how to write a for loop. For row in rows, for each row in rows, we can print the row. So that is what is happening here, and you can see the output where all the rows of data has got printed. And then we can again do another cursor.select command where we are selecting household ID, household income from household survey, where household income is greater than 60,000, right? And again we can print using this cursor.fetchAll, and then automatically direct, in this case we are storing it in rows, and then because there are multiple rows we are returning them. But here we are directly storing cursor.fetchAll into the print command, and then automatically directly it gets printed. It doesn't have to go via the rows, you know, this particular thing. So it says that output would something like this, where these are the households where the value of household income is greater than 60,000, that we can see over here. Then cursor.execute, select housing type, comma, count star average household income from household survey, group by housing type. So here we are aggregating again, and like, you know, normal standard SQL statements we can do that. And here you can see the output where you can see the apartment type, housing type. For each housing type I am counting how many of those are there. So there is 2 of these housings type, and then we are averaging the household income for this kind of housing group. So we can see that people living in townhouses are rich people. People living in detached houses are relatively poor compared to the people living in apartments. Then we can update the data in the database. That means here you can see cursor.execute update household survey, where set household income equal to household income whatever was there plus 5,000, and where household ID is equal to 8002. So for this data, this particular row ID or row of data, I am updating the income, and then con.commit is for saving it, and then I can delete also from the table where household ID is equal to 8004. So I am deleting that record, and again I am con.committing, and then I can execute a select star statement to see what is the output. So over here you can see the final output which has come. So you can see that the ID number 2 is updated. It has now become 35,000 from earlier. So this is the output table. So it has become 40,000 from 35,000 earlier, and this particular row which was earlier there, the 4th ID, this is not there now in the output. So after 3 there is 5, 4 is missing. So you see, this is how we can actually create a database without too much of complicacy, and then we can run the same SQL statements and all, and we can store data here. So sometimes when standard CSV files are not enough, we can go like this. So these are some of the references that we have utilized. And to conclude, this lecture demonstrates how Python seamlessly bridges files, spreadsheets, and relational databases, enabling robust, reproducible, and scalable data handling for urban analytics. Thank you.